Welcome to part 2 of our tutorial on calibrating the XM311K with Light Illusion's LightSpace CMS. This tutorial will specifically cover calibrating the XM311K for an HDR PQ target and assumes you have reviewed part 1 of this tutorial covering the basics of calibrating this display. We'll focus primarily on the steps unique to an HDR PQ calibration, so if you're looking for additional steps and information, please see tutorial 1. Also, keep in mind that while the calibration process may be similar with other XM models, it is important that you review specific guidelines and instructions for the monitor you intend to calibrate. To begin, we'll go to the color menu on the monitor, assure that color system is still set to LightSpace, and then switch the range over to full range, as PQ is generally used within full range. Next, we'll set the gamut option to P3ST2084, as we'll be calibrating for a P3 D65 ST2084 target. Lastly, we'll go to the luminance mode selection and set this to 1000 to bring the monitor's peak luminance up to HDR levels. Once we set this to 1000, we suggest allowing the monitor to warm up and stabilize at this level. 30 minutes is typically more than sufficient, but there is no harm in allowing for a longer warm-up time. While the monitor is warming up, it is a good idea to go to Resolve and ensure that you have switched Resolve over to full range as well. As with the SDR calibration, you want to make sure that your range in Resolve matches the range set on the monitor. Once we have allowed the monitor to warm up for some time, we'll open the File, Upload dialog again in LightSpace, ensure XM is selected, and that our monitor's IP address is typed in correctly. But we make sure we select the P3 ST2084 memory position, as that is where we'll be saving our calibration. We'll verify null cube is checked and then load the LUTs. As with the SDR calibration, we will once again load Unity LUTs to the back 1D LUT position as well as the front 1D and 3D LUT positions. With the XM311K, best results for a PQ calibration are typically achieved by first calibrating the back 1D LUT position for a neutral D65 gamma EOTF. The transformation from this gamma baseline to PQ will be done with the front 1D and 3D LUT after this step. So to calibrate the back 1D LUT for a gamma response EOTF, we'll do pretty much the same thing we did in our SDR calibration in tutorial 1. We'll go to the Quick Profile option, select Gray Only Large. We'll call this Gamma, and then we'll allow the profile to run. Once complete, we'll move over to the color space conversion window and select a color space source with a 2.4 gamma response EOTF. As we are calibrating for the 1D LUT component, the gamma is not overly important, but we'll select Rec 709 so we get a 2.4 gamma EOTF. For the destination, we'll select the profile we just performed, in this case called gamma. We'll call this LUT Gamma Back 1D, then press Create New and wait for the LUT to be generated. Once complete, we can return to the File Upload dialog, make sure our settings are still correct, select Back 1D, make sure we uncheck Null Cube so that we are uploading the LUT active in the background, and then we will load the LUT. Again, this will upload the 1D LUT component of the pictured LUT. Now that this step is complete, we'll have a neutral gamma EOTF starting point for our larger profile, which will be used to create the 3D lookup table. As with the SDR calibration, we could do a quick profile from the calibration interface and that would work reasonably well. However, in comparative testing, it is our experience that you will get appreciably better results by performing a larger display characterization when targeting a PQ color space. So that is what we will do in this case. We suggest running either a 17-sided cube or a 21-sided cube profile depending on the amount of time you have available. The 21-sided cube profile will typically take about twice as long as a 17-sided cube profile. The results are only marginally better with a larger profile, so we suggest using the 17-sided cube profile to start. Now we'll press Measure, give this profile a name, PQ for 3D, Press OK, and then the profiling starts. This calibration will take some time, so we'll come back to it when complete. Now that our large display characterization is complete, we can return to the color space conversion window. We'll select ST2084P3D65 as our source color space. Then in our destination dropdown, we will select the large profile we just performed. And next is a critical step for PQ LUT generation. In this EOTF NITS dialog, we need to enter the peak measured luminance value that occurred during our large display characterization. In this case, 965 nits. This will allow the PQ LUT to be generated correctly with a hard clip. Next, we find that you can get optimal results by selecting the hybrid export option when calibrating for PQ targets. Finally, we will select Create New to generate our lookup table. Once generated, we can see the hard clip nature of the generated LUT reflected in this view. We can now upload our lookup tables from the File Upload option, then select 1D plus 3D to upload our LUTs to the front 1D and 3D LUT positions. Our calibration is now complete. As with the SDR calibration, we can perform a quick profile if we like now to validate our results. We hope this video has provided a useful overview on PQ calibration of the XM311K, but feel free to reach out to our support department at support@flandersscientific.com with any additional questions. Thank you.